time graph. So, Tenuk and Himansi, since you're new today, just to give you a little update, we actually finished the first lesson and now we're in the second lesson. Second lesson again, Antim Hari inne, because last week we finished that displacement time graphs and today we are starting velocity time graphs. Okay. So, okay. Put the topic velocity time graphs. I think, Shahnaz, you should increase the volume from your end because the volume is increased to the maximum from my end. Can others hear me well? Can somebody tell me if you can hear me well? Okay. Then, Shahnaz, try increasing the volume from your end and see if it works. Put the topic velocity time graph. Tenuk and Himansi, since you're new today, can you send your WhatsApp number to the chat box? You can send a personal message to me. Shehani, are you a newcomer today? Shehani, are you a newcomer today? Let me know. Anyways, Tenuk and Himansi, let me know your WhatsApp numbers and so that we can contact. Okay. Okay. So, we will draw now velocity time graphs tamai lamai vadipurama papers wala ahanne. They ask mostly about the velocity time graphs. So, let's see what this is. So, let's look at this graph. These are the details, right? The data. So using this data, I'm going to draw a graph. So when you're drawing a velocity time graph, we have the y-axis and we have the x-axis. Okay. So y-axis is velocity. Always y-axis has velocity and the x-axis has time. Usually, when you are labeling the axes, y-axis and the x-axis, within brackets, you also have to write the unit. So, time wala unit seconds ne. So, within brackets, you have to write seconds. Velocity, the unit is ms minus 1. So, within brackets, I write ms minus 1. Okay. So, Balanna, when the time is 0, now time is 0, 1, 2, 3, 4, 5, 6, 7. So, mama ek me pate mark karanna 0, 1, 2, 3, 4, 5, 6. 6 and a kangne yes. So, let me draw the graph here and then I will mark the velocity values. Otherwise, I have to values in hinda. So, when the time is 0, velocity is also 0. When the time is 1, velocity is 3. When the time is 1, velocity is 3. When the time is 2, how much is the velocity? When the time is 2, velocity is 6. When the time is 2, velocity is 6. When the time is 3, velocity is 9. Yes. And when the time is 4, velocity is? When the time is 4, velocity is? 12. And when the time is 5, velocity is? 15, and when the time is 6, the velocity is
18.
18. Okay. So this is the velocity time graph. Okay. Now we have to get some very important things from the velocity time graph. First of all, we are going to get the gradient of the graph. Now, last week also we learned how to get the gradient. Now, how do we get the gradient? We need 2 points to get the gradient. Man ekka point ekak ganna, the very first point. And what are the coordinates of the first point? X value is 0, y value is also 0. Okay. එතකොට මේ first point එකේ x value එක, so this is x1. This is the y value of the first point, so we call it y1. Then I take another point here at the very end point. Or කැමති තැනක point එකක් points දෙකක් වට ගන්න පුළුවන්. You can get any 2 points you want. I take the very first point and the very last point. Can somebody tell me the x value of this point? What is the x value of this point?
80. Sorry.
X value? Yes?
6.
6. Then what is the y value?
Well, 18.
18. Yes. So, second term make x value vega, so I give this x2. Then second point ke y value vega, so I call this y2. So I have x1, y1, and I have x2, y2. Then how do we get the gradient, Lamai? Gradient equals y2 minus y1 divided by x2 minus x1. So y2 is 18, y1 is 0. So y2 is 18, y1 is 0, so 18 minus 0. x2 is 6, x1 is 0. So x2 is 6, x1 is 0, so 6 minus 0. 18 minus 0 is 18, 6 minus 0 is 6. So 18 divided by 6, what is the answer? 18 divided by 6.
3.
3. Make a gradient එක 3. Now lamai balanna y2 minus y1 means I got y values now. What is the y-axis in this graph? What is in the y-axis in this graph? Quickly tell. What is in the y-axis of this graph?
Velocity.
Velocity. Then method denominator ke mang aran x2 minus x1. That means the x values. What is the x-axis of this graph?
Time.
Time. Velocity divided by time. What do we get? What is velocity divided by time? I can't hear.
Acceleration.
Acceleration. In a velocity time graph, from the gradient, you get the acceleration. If the gradient is 3, then we can say therefore acceleration is 3 unit එක දානවා ms minus 2. 3 ms minus 2. Yes, Ashish. What is the question?
Teacher, when you said the answer is acceleration, doesn't velocity doesn't it become final velocity minus initial velocity divided by time?
Yes.
How
Final
can we
velocity
take
minus initial
all of
velocity.
it as one way?
Yes. So here we did that only to get an idea. So y values is always velocity, x values are always time. No? So velocity divided by time is roughly acceleration. However, when you actually do the calculation, acceleration equals final velocity minus initial velocity divided by time. When you actually do the calculation. But just to get an idea, velocity divided by time is acceleration. Okay, Sasheli?
So they all come together, right? Final and
Yes. I mean, final
and
velocity.
initial velocity, they all come together to make one.
Not exactly together, but final velocity minus initial velocity, you get a certain velocity, no? So velocity is ms minus 1 divided by time is seconds. So ms minus 1 divided by seconds තමයි අපිට ms minus 2 එන්නේ. And that is the unit of acceleration. Roughly ගත්තොත් velocity divided by time is acceleration. However, if you get like the proper equation, acceleration is equal to final velocity minus initial velocity divided by time. When you like properly do the equation. But just to get an idea only, velocity divided by time is acceleration. Okay?
Yes, teacher, thank you.
Okay. මොකද anyways මෙතන y2 කියලා කියන්නේ මේ final velocity එක තමයිනේ 18. y1 කියලා කියන්නේ initial velocity එක තමයි කොහොමද. So final velocity minus initial velocity තමයි කොහොමද එතන. So always remember in a velocity time graph the gradient gives the acceleration. Is that clear to all of you? Give me a thumbs up if it's clear, Lamai. For the newcomers, always when we do the communication, you can unmute and talk to me. You can put the answers or whatever in the chat box, or you can give thumbs up. If I ask like yes or no questions, you can give give thumbs up, thumbs ups. Yes. Anyways, so up to that point, it's clear to all of you. Okay. Then, how important එකක් තියෙනවා. In a velocity time graph, now this is the graph now. මේ තියෙන graph එක. If I want to calculate the area under this graph, මේ graph එක යට තියෙන area එක calculate කරන්න ඕනේ මට. Right, area under the graph. So what is the shape of this part? What is the shape of this area under the graph?
Triangle.
It's a triangle, yes. So let's just calculate and see. Area under the graph. And it is a triangle. How do we get the area of a triangle, Lamai? You know, ne? How do we get the area of a triangle?
Half into base into height. Half into base into perpendicular.
Yes. Half into base into perpendicular height. Then බලන්න මෙතන base half මේ තියෙන base එක. So base එක කියන්නේ 6 no? මෙතන total value එක 6 නේ. So base is 6. Perpendicular height කියන්නේ මේ ටික and that is 18. Perpendicular height is 18. Then we will simplify this. 2 times 1 is 2, 2 times 3 is 6, 3 times 18, so 3 times 8 is 24, 2 remaining, 3 times 1 is 3, 4, 5, 54. Area under the graph, what I know, 54. Is that clear? Area under the graph, it looks like a triangle, so I calculated the area using the formula for finding the area of a triangle.
Yes.
Yes.
Can you explain once more?
Yes. So now here, now this is the graph, my graph, my graph. If you look at the area under the graph, that means this section, that looks like a triangle. So how do I get the area of a triangle? Half into base into perpendicular height. Half into base that is 6. Perpendicular height 18. So half into 6 into 18, when I simplify, I get 54. Okay, so that is the area under the graph. Remember, Lamai, in a velocity time graph, area under the graph gives displacement. If the area under the graph we get 54, that means may object take displacement take 54 meters. So in a displacement time graph, all we have to know is the gradient gives the velocity. That's it. But in a velocity time graph, gradient gives the acceleration, number one. Also, area under the graph gives displacement of that object. Is that clear to all of you?
Yes.
Yes. Can you quickly copy this down? Can
Including
you?
the graph.
With the diagram.
Yes, with the diagram. Put the topic, may table and may graph and then write all of this. I will give a few minutes. I won't set a timer, but I will give you some time.
Teacher,
Yes.
in here, the equation is gradient equals like you get the answer as 3, right? So
Yes. This
you gave us that gradient equals velocity. So how come the answer becomes acceleration instead of velocity?
That was in displacement time graphs last week. In displacement time graphs, the gradient gives the velocity. But this is velocity time graph. Here, the gradient gives acceleration. Okay.
So in displacement gradient equals velocity, and in velocity graphs, gradient equals acceleration, right?
Yes. Yes. That's right. Is it clear?
Yes.
Okay. Quickly write Lamai. Let me know when you're done. Shehani Silva and Jason, please let me know if you are new to the class today. You can let me know in the chat box.
Miss,
Yes.
in area under the graph, the displacement is 54 meters. So for what is that is like equal to displacement equal to?
Displacement is equal to the area under the graph. So that means now let's say when you are given like without a graph, you know how to do the calculations. But with a graph, there are different ways how we can get the same answer. So it's like a shortcut. It can a displacement now in a velocity time graph, acceleration one pull what a gradient again. In a velocity time graph, displacement you can find using the graph. They are just shortcuts for velocity time graph.
So
Okay.
Miss, does that mean area means like displacement also?
Yes, make a graph area calculate that means that the number you get is the displacement of that motion. Displacement is the distance moved, right? So displacement you can get by calculating the area under the graph. Okay.
Finish,
Okay.
Miss.
All right. For others also, I will give like 2-3 more minutes. Make sure that you write faster. Who needs more time, Lamai? Anybody who needs more time? Okay.
It's a bit more time.
Okay. So I will give like 2-3 more minutes. Quickly finish. Lamai, 1 more minute. I have to tell, since you are still in grade 10, you are still at the beginning of grade 10, but you have to, I might have told this already, but you have to work on your speed, right? Speed is very important, especially for papers like science, maths, and Sinhala, because time is always, you always run out of time when it comes to these papers. Of course, you have to write neat and tidy, but don't try to perfect it. Okay, what matters more is that you write fast. Because as I might have again already told you, when you write fast, you need less time to write, so you have more time to think. Especially when it comes to papers. Why do you run out of time? Because you take time to think now, and then you start to write. Your writing is slow, that would take a lot of time. But if you write faster, you will have more time to think, right? And you will not have time-related problems. So your writing speed is one of the main problems when it comes to time management in your term test papers or your O-level papers. Because always remember, even though you're still in grade 10, what are we preparing for? What is our end goal in grade 10 and 11? What is our end goal?
O-levels.
O-levels. Our end goal is O-levels. Always remember, next year at the end, you will be doing O-levels and you will think, nothing to worry, tava 2 years තියෙනවා. Yes, nothing to worry, 2 years තියෙනවා, but time flies. So without you even knowing, it will be 2027 and it will be December and you will already be writing O-levels. So that's how fast time goes, even without us realizing. Okay. Then February ලියන කට්ටිය ඒගොල්ලන්ගේ මීට අවුරුද්දකට කලින් හිතුවේ තව ගොඩක් කල් තියෙනවා කියලා, but it's already February. So time goes really fast. And if you do work little by little now, you will have less stress to handle at the end. But if you don't work at all and if you just slack off, what will happen is that it will all pile up and at the end it will be a lot of stress. And that is unnecessary stress. දැන් ඉන ඔයගොල්ලන් පොඩි පොඩි කියන්නේ let's say science podi velawak revise karna, maths podi ganan deka tunak karna, daily chutta chutta karama, that would be more than enough. Because now we are still in the second lesson. You don't have much to study. Just go through what we have done. Just take a few minutes. Of course, you are still young. You have to hang out with friends. You have to watch TV. You have to do play or whatever. I don't think you guys play now, but watch TV or whatever. Make it a podi time ekak den. Allocate a certain amount of time. It doesn't have to be like you don't have to study 10 hours a day or like that, because you are still in grade 10. But even then, you have to revise little by little every day. Okay. Especially maths, science, Sinhala wage subjects. And now I know a lot of you struggle with history subjects. So because of that, do it like that, unless you want stress at the end. Okay. That exam langunam ugulang pisuhadlage natanawa, I could do this, I could do that, and you have a lot of regrets. We don't want that, no. So let's do little by little. I'm not asking you to do a lot. Little by little, slowly, let's revise every day. That is more than enough. Okay. I think now it would be enough time, no? Everybody done writing? Give me a thumbs up, please. Okay. Okay. All right. Now we are going to do a question. Right? This question I'm not going to let you do alone. We will do together. Right? Once we do a question together, then I will give you a question to try alone. මෙන්න මෙහෙම question එකක්. Put Q and write the question. You can write with me. Quickly write this question. Q Kiradala, write this question fast.
Yes.
Done?
Yes.
Okay. Now look at this question. An object starting from rest. If the object starts from rest, what is the initial velocity of the object?
0.
If it's 0. So I'm going to now, I don't have all the data. The full detail table. So they have given only limited data. From that data, we have to draw the graph. So in this question, they have said starting from rest. So you know the initial velocity is 0 and obtains a velocity of 10 ms minus 1 within 4 seconds. Okay. This is more than enough information for us to draw a graph. Okay, we will draw a graph. This is, 1 second. So this is my y-axis. This is my x-axis. I just have to sketch it. I don't have to like properly measure and draw. They have said sketch. So I will just sketch. So y-axis is velocity. Within brackets, always you have to put the unit. ms minus 1. Here this is time. Within brackets you put seconds. So the initial velocity is 0, right? Here my graphic is 0 वलिन तमाई start करना obtains a velocity of 10 ms minus 1 within 4 seconds. So this graph, starting from here, like this. And here what should be the velocity? The object has obtained a velocity of 10, so here the velocity is 10. And here 0, and here the time is 4. Like this. So as we can see, the object started from rest. So we start from 0, obtains a velocity of 10 ms minus 1 within 4 seconds. So the time is 4 seconds, and this object has gotten the velocity of 10 ms minus 1. This is the sketch that you have to draw. It doesn't have to be perfect. You don't have to measure, but of course you have to use a ruler and draw straight lines. So that is my first answer. Second one, find acceleration. How do you find acceleration from a velocity time graph? How do we find the acceleration from a velocity time graph? Now you know already. We did it a few minutes ago.
Find the gradient.
Yes, we have to find the gradient. If I have to find the gradient, I need 2 points. So what are the 2 points that I'm going to select? I'm going to get the starting point. Here starting point, okay, x value is 0, y value is also 0. So when you write the coordinates, you first write the x value, then you write the y value. So x value is 0, so x value of the first point and y value of the first point is also 0. If you take this point, x value is 4 and y value is 10. So 4 is the x value of the second point, so it's x2. 10 is the y value of the second point, so that is y2. So I have x1, y1 and I have x2, y2. So I can easily calculate the gradient. Gradient equals y2 minus y1 divided by x2 minus x1. So y2 here is 10, y1 is 0. x2 is 4, x1 is 0. So 10 minus 0 is 10, 4 minus 0 is 4. So 10 divided by 4, you can divide and see, you get 2.5. And now what is the acceleration of this object? What is acceleration?
2.5.
Yes, 2.5. But do you just put 2.5 for acceleration?
2.5 mf minus 2.
2.5 m minus.
Yes, good. 2.5 ms minus 2. Good. We must put the unit. If we don't put the unit, what will happen? Your answer is wrong. Calculations corrupt. The moment you get the unit wrong, your final answer is wrong. They won't give marks. Always keep that in mind. Okay? Now we calculated the acceleration. Roman number 3 is find the displacement of the object. Now from a velocity time graph, how do I get the displacement? From a velocity time graph, how do I get the displacement?
Find the area.
Find the area under the graph, right? So this is the graph now. So I have to get the area under this graph. What is the shape of this area under the graph? What is its shape? Hmm? Go ahead, Lama. Koda anittage sabdyak naha. Yes, triangle. Yes, it is a triangle. What about others? Now, always the same one of you give answers, which is very good. That is very good because I want you all to interact. Nata harima boring. It's boring for you also, no? If you actively reply, if you actively answer, then it's interesting for all of us. Nata ogalang ottani dagana nidagan innawada kiyala mama danne. You have the camera off, no? So I don't know if you're sleeping. But if you don't answer, I will assume you're sleeping. Okay? So make sure you answer others too. Huh? Everybody, you have to answer. The newcomers too. Whatever you understand, whatever you get, you answer. Okay? Whether it's correct or wrong, we'll talk about it later. Api discuss karande. Correct, not correct, wrong. It doesn't really matter. No one's judging. So whatever the answer you feel is correct, you tell that answer. Whether it's right or wrong, we will discuss. Okay? I want all of you to interact. That is the most important thing. So this is a triangle, no? කොහොමද අපි triangle එකක area හොයන්නේ? Half into base into perpendicular height. So half into what is the base of this triangle? What is the base of this triangle? 4.
4.
Yes. And what is the perpendicular height of the triangle?
10. 10.
Others?
10.
10. Perpendicular height is 10. Now we will simplify. 2 times 1 is 2, 2 times 2 is 4, and we have 2 and 10 remaining. Yes. 20 is the area under the graph. Yes. Then what is the displacement?
20 meters.
Others also think the same? Same answer?
Yes.
Yes. 20 meters. Again, the unit is very important. You get the answer, okay, but if you don't put the unit, no marks. So make sure you put the unit. Is that clear to all of you, Lama? Give me a thumbs up. Everybody. If it's clear, give me a thumbs up. If it's not clear, ask me questions. Yes, Sal, any question?
Miss, for displacement, we are only putting meters.
Yes. Because displacement is a length, no? So the unit is meters. Okay.
Okay, Miss.
Okay. Anita, ko hamotu the Chalukya, Dihansa, Himansi. Who else didn't give a thumbs up? I only saw, okay, all right. I think everybody said yes. There are a lot of you, so sometimes I lose track, but I hope it's clear to all of you. Huh? If not, please do ask questions and clarify. All right, so let's copy this down. And the next question you have to do alone. Okay, copy this down. To copy this down, I will give you like 7 minutes.
That is.
Okay, already? Okay, good. Others also copy it down. A lot of you seem to be done. I think this would be too much. I'll leave 5 minutes for those of you who have not yet done. Huh? Lamai, while you copy this down, give me 2 minutes. I will quickly be back. You have 2.5 more minutes. For those of you who have not yet finished, quickly finish. Okay, Lamai. Done? Shall we move on to the next question? So write this question with me. Okay. So an object has a now Balanda, this object is not starting from rest. This already has an initial velocity of 25 ms minus 1. The velocity of the object is uniformly reduced and it comes to rest within 5 seconds. So initial velocity is 25 ms minus 1. It comes to rest and all of that happens within 5 seconds. Now try doing this alone. Just think of what you have learned and do the answer. Don't worry too much about is this right, is this wrong. Just remember what you have learned and ඒ විදිහට කරන්න. හරිද වැරදිද කියන එක we will correct it after you finish. Okay? I won't set a timer, but you can let me know when you're done. Okay, chop quickly.
Miss, initial velocity means the starting time.
The starting velocity, yes. Ramai, for those of you who are still doing, I will give you like two more minutes. Quickly do. I think we will start discussing. So, an object has an initial velocity of 25 ms minus 1. Then the velocity of the object is uniformly reduced and it comes to a rest within 5 seconds. Okay. Sketch the velocity time graph. මුලින් අපි velocity time graph එක sketch කරලා ඉමු. Okay. So we know the y-axis is the velocity and the x-axis is time. So Roman number 1, y-axis is velocity. And x-axis is time. So, an object has an initial velocity of 25 ms minus 1. එයා start කරද්දිම it already has a velocity. Start කරද්දි 25 ms minus 1 and it comes to rest. Comes to rest කියන්නේ what is the final velocity? Comes to rest means what is the final velocity? Anamai? Yes, if the object comes to rest, that means the final velocity is 0. So initial velocity is 25. Final velocity is 0. Metana time එක කීයද? 5 seconds. Is this how you plotted the graph? Can you give me a thumbs up if you did it like it? Others? Tatsarani, Yapa Bandara, Tarusha, Shineshi, Sala, Nikini. Then did I miss any others? Also, can I know Yapa Bandara, are you new today? Are you a newcomer? Please let me know in the chat box. So anyways, yes, this is how the graph goes. Then, any question, Lamai?
Miss, I didn't get it.
But did you understand, Sala?
Yeah, Miss, we did the graph in other way, right?
Yes, earlier we did it in a different way. Because earlier the object started from rest, so the initial velocity was 0. And then it obtains a velocity of 10, so the final velocity was 10. But if you take this graph, this already has an initial velocity, 25, and it comes to rest means final velocity is 0. So depending on the question, the shape of the graph can be different. Okay, Sala?
Okay, miss.
Okay. So in a velocity time graph, we know how to get the acceleration using the gradient. To get the gradient, we need 2 points. So this is my first point. What is the x value of this point? What is the x value of this point?
Fine.
Are you sure?
Miss, I got 5.
Okay, 5. I also get the answer 0. Paladna,
Zero.
if you look at this point, yes. May point එකට correspondent x value එක තමයි අහන්නේ. So මෙතන x value එක 0. එහෙනම් මේ point එකේ x value එක 0. So x1 is 0. Is that clear ළමයි? And මේ point එකට අදාළ y value එක කිව්වොත් ඒකට correspondent y axis එකේ ඉන්නේ 25. So the y value is 25.
I took it
Yes.
as like
Sorry.
I took x1 as
Sorry, I
0
didn't hear. Can you repeat?
I took x1 because of us as 0 because I thought that x1 will always be 0 because you are like what do you call that? You're like adu karana from something bigger from to a
Yeah.
smaller number.
එහෙම කියන්නත් බෑ. හැබැයි smaller number එකකින් bigger number එකක් අඩු කරන්නත් පුළුවන්. ඒතර minus වලින් answer කියන්න පුළුවන්. නේද? Like 3 වලින් 5 subtract කරොත් 3 minus 5 would be minus 2. And minus 2 is still a value. So එහෙම අපිට ගන්නත් බැරි නෑ. Okay, Sasheli?
Okay, teacher. Thank you.
Okay. So එතකොට හැම වෙලේම A point එකට හැම වෙලේම when you are asked to write the coordinates of a point, you consider that point A point එකට අදාළ x value එක ගන්නවා, A point එකට අදාළ y value එක ගන්නවා. Then if you look at this point, what is the x value correspondent to this point? What is the x value correspondent to this point? Anamai?
0.
5.
X value correspondent to this point, may point එකට අදාළව x axis එකේ ඉන්නේ 5. So it is actually 5. So listen again. You get a certain point. That point could be anywhere on a graph. You get that point, or a point එකත් එක්ක x axis එක දිහා බැලුවම you get the x value. A point එකත් එක්ක y axis එක දිහා බැලුවම you get the y value. මේ point එක මෙතනනේ. ඒ point එකත් එක්කම x axis එක දිහා බලද්දී you can see the x value is 5. එහෙනම් මෙයාගේ x value එක 5. So that is x2. A point එකත් එක්කම මම y axis එක දිහා බලද්දී the y value is 0. එහෙනම් y value of this point is 0. So x1, y1 are the x value and y value of the first point. X2, y2 are the x value and the y value of the second point. Is this clear to all of you? Can you give me a thumbs up if it's clear?
Can you explain again? I got the answer, but I just like guessed it. I didn't actually got the way.
Okay. So I will explain it again. Now, if you take this graph, the graph starts from here, right? The graph starts from here. So this is the first point. So first point ke x value එක කියලා කියන්නේ you take the first point and taking the first point you look at the x axis. X axis එක කියන්නේ මේකනේ. එතන තියෙන්නේ 0. Then the x value of the first point which is x1 is 0. Then you take that point and corresponding to that point you look at the y axis and you get 25. So that is the y value of the first point, so it's y1. Then මේ graph එක මේ යනකොට මට දැන් මේ මැද values එකක්වත් මම දන්නේ නැහැ, but I know this point. So corresponding to this point, I look at the x-axis, and I get that the x value is 5. So the x value of the second point, which is x2, is 5. Then corresponding to that point, I look at the y-axis. So y-axis එක එතන තියෙන 0. So y value of the second point is 0, therefore y2 is 0. Is that clear to all of you, Lamai?
Yes, miss. Thank you.
Okay. So gradient එක කොහොමද අපි ගන්නෙ? As usual, gradient equals y2 don't worry about minuses, all that වැඩි හිතන්න එපා. අපි ඉගෙන ගත්ත විදිහට කරනවා. y2 minus y1 divided by x2 minus x1. y2 is 0. See, y2 is 0. Yes, Jason. But you will have to check the sign. The sign. y1 is 25. So 25. x2 minus x1. x2 is 5. x1 here is 0. 0 minus 25 is minus 25. 5 minus 0 is 5. So 25 divided by 5, I get the answer as minus 5. Therefore, acceleration is, what is acceleration here, Lamai?
Minus 5 ms minus 2.
Minus 5 ms minus 1.
Minus 2. Minus 5. Yes. Minus 5 ms minus 2. So that is the answer. So බලන්න එන්න velocity අඩු වෙලා කියලා කියන්නේ what has happened is actually a deceleration, right? So මේක අහලා නැහැ question එකේ, but if I asked you what would be the value of deceleration? If the acceleration is minus 5 ms minus 2, what is the deceleration, Lamai?
5 ms minus 2.
5 ms minus 2. Always, if you get a negative value for acceleration, that means the velocity is slowly decreasing. That means it's actually a deceleration. So if you get a negative value for acceleration, minus sign එක අයින් කරලා value එක ගන්නවා deceleration වලට. So එන්න velocity අඩු වෙලා කියලා කියන්නේ ඇත්තටම decelerate වෙලානේ තියෙන්නේ. හරියට නිකන් brake පැග්ගුවම වගේ, right? So if the acceleration is minus 5 ms minus 2, deceleration वाली minus එක අයින් කරලා 5 ms minus 2. That is the deceleration.
So, Riji, if the answer was minus 5 ms minus 2, do we write it as 5 ms minus 2?
In the question, they're asking acceleration. So writing minus 5 is okay. So this is an additional point that I said. If they ask deceleration, you get the same value as acceleration, but you change the sign. Now here the acceleration is minus. So you remove the minus and you put a plus for deceleration. But here they have asked acceleration, so we can just put minus 5 ms minus 2. හැබැයි ඇත්තටම වෙලා තියෙන deceleration එකක් නේ. If they ask deceleration, acceleration වල negative sign එක අයින් කරා ඒ value එක හැම්පිටින්ම ගත්තා. Okay, Jason?
Okay, Riji.
Okay. So deceleration, if they ask, that would be 5 ms minus 2. Is that clear to everybody? Thumbs up, please. Others? Alia, Chalukya, Vihansa. What is this, Asheri?
What's the difference between acceleration and deceleration?
So acceleration means the vehicle එක accelerate එක පෑගුවාම N velocity value, that is acceleration. Sorry. So if we press on the accelerator, that will Lama, can you hear me?
Teacher, you are lagging.
You're lagging.
Okay, 1 second. Can you all hear me now? All right. So as Sashali asked, acceleration means, let's say your father is driving the vehicle and he steps his foot on the accelerator. If he steps on the accelerator, the velocity will gradually increase, right? Velocity so it is an acceleration. But if he steps on the brakes, the velocity will gradually decrease. That is called deceleration. So ඒකයි මෙතන acceleration වල minus value එකක් ආවේ because මතන ඇත්තටම වෙලා තියෙන acceleration එක. Is that clear, Shelly?
Yes, miss.
Okay. Anyways, then Roman number 3. They're asking the displacement and we know how to get the displacement area under the graph. So metanath area under the graph is a triangle, no? So we have to use half into base into perpendicular height. So area equals half into what is the base here?
5.
5, and what is the perpendicular height?
25.
The perpendicular height is 25. So what is the area you got here? Five times, yes.
2.5.
Others? I'm getting the answers in the chat box also. 5 times 25 is 125. Divided by 2, that would be 62.5. If the area you get as 62.5, we know the area gives a displacement. Therefore, displacement equals 62.5 meters. Is it clear, Lamai? I hope that's clear to all of you. Okay. Remember in displacement, in displacement time graphs, we looked at a few different shapes, no? In the velocity time graph also, we will look at some general shapes, right? Just to understand. Okay. Don't write anything, just listen. Explain කරද්දි මුකුත් ලියන්න එපා. Explain කරද්දි explain කරන එක අහන් ඉන්න ඕනේ. Excuse me. Velocity unit is හැමලේම graph එකක unit එක දාන්නම ඕනේ. Time within brackets you have to put second. So in a velocity time graph, if you get a shape like this, what does it mean? What can you say about the object? If the shape is something like this, what has happened? You can see with the time the velocity has increased. So what has happened here? It is an acceleration, yes. So velocity has gradually increased with time. Therefore, so we say the object is accelerated. Or we can say, therefore, this is an acceleration. Is that clear? Don't write or draw. Please don't write or draw. Just listen. Is this clear to all of you? Others? All right.
Yes.
Okay. Then what if you get a shape like this? What if you get a shape like this? What can you say about the motion of this object? What can you say about the motion of this object? Quickly tell Namai. This is quite obvious.
Velocity or the
Right
time
angle.
in the object is at rest.
Yes.
The object is at rest.
Yes. The velocity is constant, but the velocity is zero. So velocity is zero can obviously the object is not moving. Let's say car ke vaadi vela inna, but you have not started the car yet. Then the velocity is zero. So the car has not yet started. So you are not moving. So the object is at rest. Velocity is constant with time, but the velocity is zero. So velocity zero means the object is not moving. It is at rest. What if you get a graph like this? Here, what can you say about the motion of the object? Yes, Maria. Others? Time එකත් එක්ක what has happened to velocity? Can I ask a question like this? I will ask a very basic question about this motion. Is the object moving or not?
No.
Okay.
Yes.
Okay. Some of you say yes, some of you say no. Just a very simple yes or no question. Is the object moving or not?
No.
Okay.
No.
Okay. බලන්න displacement time graph එක මෙහෙම තිබ්බොත් නම් the object is not moving. මොකද displacement එක වෙනස් වෙලා නැහැ. But here velocity is constant with time, but there is a velocity, right? Let's say මෙතන 10 කියලා. That means a object එක 10 meters per second කියන speed එකේ දිගටම යනවා. So the object is moving, but it is not accelerating, it is not decelerating. It is going at a uniform velocity, but it's moving. හිතන්න ඔයගොල්ලෝ දැන් highway එකේ එහෙම යනවා කියලා expressway එකේ යනවා කියලා. I'm pretty sure all of you have gone on the expressway at least once, right? So let's say speed limit එක 100 කියලා. So your father or your mother or whoever is driving exactly at 100. 100 කියන speed එකේ දිගටම යනවා. Without increasing the speed or decreasing the speed. Now that is uniform velocity. ඒකට ඔගේ graph එක අඳින්න පුළුවන් අපිට. හැබැයි හිතන්න speed එක 80 නම් 81, 82, 83, 85, 90, 100, 110 ඔහොමම වැඩි වෙනවා නම් that is acceleration. Then let's say 100 ඉඳන් 90, 80, 70, 60 කියලා velocity අඩු වෙනවා නම් that is deceleration. But එකම velocity එකකින් දිගටම යනවා නම් that means it's a constant velocity. It's a uniform velocity. So here, the object is moving at uniform velocity. How do we say that? Because the velocity does not change with the velocity is constant with time. Therefore, we can say the object is moving at uniform velocity. Is that clear, Lamai? All right. Okay. What if I draw a graph like this? What is happening to this graph? What is happening to this graph? Yes. Others?
It increase down deceleration.
Yeah. Can you see that as the time is going, the velocity is gradually decreasing. So the velocity is decreasing with time. So this is a deceleration. So these are all the different types of shapes that you can get for the velocity time graph. May I shapes in there? These are all the possible shapes. Okay, can you all copy this down? Onna podi point එක කොටින් දාගන්න. Given below are the general shapes of the velocity time graphs. කියලා පොඩි point එකක් දාගෙන draw these 4 shapes with a small description as I have written at the bottom. Okay, make it fast.
යන්නද කියන්නේ
Kushit, did you say something?
ඒක යන්නද කියන්නේ
Oh, medically Anna. මෙන්න මේ point එක given below are the general shapes of the velocity time graphs කියලා මේ shapes හතරම ඇඳලා මේ යට තියෙන points ටික ලියන්න. ඉක්මනට ලියා ගන්න. I'll give you 1 more minute. 1 or 2 more minutes. Okay, Lamai. So, I hope everybody's done since I gave some time. We are going to do a question together. So now this is a bit of a, not a difficult question, but it's a bit of a long question, right? So maybe long questions are going to but this question we will do together, and then I will give you a question to try a look. You will have to write this question because this is an example in the textbook. Make a textbook textbook questions it's just an example. So you will have to write this question, but first of all, listen. We will discuss this question first. All right. An object starting from rest. So I will highlight the important ones. An object starting from rest. Starting from rest means what is the initial velocity? Starting from rest means the initial velocity is? Yes,
Zero.
other 0. Acquires a velocity of 15 ms minus 1 after moving for 6 seconds under uniform acceleration. Starting from rest, gets a velocity of 15 ms minus 1 within 6 seconds. They make up a velocity time graphic, a plot karanne pe, so I will start by plotting that. So, velocity and time. So the y-axis is velocity measured as ms minus 1 and the x-axis is time measured in seconds. So this object is starting from rest. Starting from rest means it's starting from 0 and acquires a velocity of how much? 15, no? 15 ms minus 1 within 6 seconds. Draw something like this. So here the velocity is 15 ms minus 1 and time the time is 6 seconds. Okay? then the object moves with that velocity for 6 seconds. A velocity may move in all 6 seconds. That means the velocity is not changing. It is moving with the same velocity for 6 seconds. Look at that. Then what is the time here? What is the time here? Alamai? Not 3. So, it starts from 0. And it acquires a velocity of 15 ms minus 1 within 4 seconds. ඊට පස්සේ එයා a velocity එකම move වෙනවා තව 6 seconds. So මෙතන time එක 6, තව 6 seconds ගියාම now the time is 12. Is this up to this point, is it clear? My thumbs up. දැන් මෙතන combine වෙලා shapes ගොඩක් තියෙනවා නේ. All right, then what happens? Moves with that velocity for 6 seconds. ඒක තමයි මේ draw කරේ. Then comes to rest after decelerating for 3 seconds. තව 3 seconds වලදී මෙයා decelerate වෙලා 0 වෙනවා. So 12 ඉඳන් තව 3 seconds ගියාම now what is the time? What is the time here? 15. Is the graph part clear to all of you? Okay. Let's move on to, there are several Roman numbers, right? Let's move on to Roman number 2. What does Roman number 2 say? Find the acceleration during the first 6 seconds. First 6 seconds can mean the ටික, right? එතන acceleration එක පෙන්වන්න ඕනේ. Now you know how to get the acceleration using the gradient. So this is the section that I have to consider now. In this section, I need 2 points. So my first point is here. Here the x value is 0. Y value is also 0. Then I have this point. What is x value of this point? What is x value of that point? 6. And what is the y value of that point? 15. Y value, that is 15. So 15 is y2. So here now we will calculate the gradient. Gradient equals y2 minus y1 divided by x2 minus x1. y2 is 15, y1 is 0. x2 is 6, x1 is 0. So 15 divided by 6. What is the answer you got here? I mean, you didn't do it, no? Sorry. So we have to divide 15 by 6. 6 times 2 is 12. 3 remaining. I put a 0 here and I put a decimal mark here. 6 times 5 is 30. And our answer is 2.5. If the gradient is 2.5, I know the acceleration is 2.5 ms minus 2. Is that clear to all of you? Others? Okay. Next question. Find the displacement during these 6 seconds. Can we first 6 seconds or displacement handle? How do we get the displacement from a velocity time graph? We know that acceleration you get from the gradient. How do you get the displacement?
Area.
From a velocity, yes, area. So if you take the first 6 seconds, now this is a triangle. Excuse me. So triangle, like now we have to go with half into base into perpendicular height, yes. So Roman number 3, we'll get area. Half into, what is the base here? What is the base here? 6. And what is the perpendicular height here? 50. So base is 6, perpendicular height is 15. So 2 times 1 is 2, 2 times 3 is 6. And 3 multiplied by 15 is 45, right? That is the area. Then what is the displacement, Lamai? Hmm? 45 meters. So that is the displacement. So Shanaz, we were discussing about this graph. So we drew the graph now starting from rest, gets a velocity of 15 ms minus 1 within 6 seconds. So a velocity came another 6 seconds. So now the time is 12. And then it has decelerated. For that, it has taken 3 seconds. So now it's 15. Acceleration during the first 6 seconds. We take the first 6 seconds and we find the gradient because we get the acceleration from the gradient. So we have 2 points, x1, y1, x2, y2. From that, we calculated the gradient as 2.5. So the acceleration is 2.5 ms minus 2. Then the next question was finding the displacement during the first 6 seconds. So displacement one area under the graph. Now this is a triangle. No? So triangle like a half into base into perpendicular height. So base is 6, perpendicular height is 15. So aking up to 45 kg. So the displacement is 45 meters. Then Roman number 4. What is the displacement traveled under uniform velocity? So uniform velocity means same velocity. Same velocity ke gya kya ne in the may section. How do I find the displacement of this section? How do I find the displacement of that section? Alamai? How do you find the displacement of a velocity time graph? Generally, in a velocity time graph, how do you get the displacement?
Area.
Area. So area under the graph. So now here in the uniform velocity part, that means this part, no? Meag area ka kiyane minne meka. The area under the graph is this part. What is this shape now? Alamai, what is this shape? Rectangle. And rectangle like a area ka ganne length into breadth. Okay. So methana length eka length ka kiyane metikane. What is the length here? What is this length here? 15. And what is the breadth here? 6. I made a gap like a 6. Breadth is 6. Length is 15. And now length into breadth, you get the area. So Roman number 4, area equals length is 15, breadth is 6. So 6 times 5 is 30, 3 remaining, 6 times 1 is 6, 7, 8, 9. So area is 90. If the area is 90, displacement there would be 90 meters. Up to that point, is it clear? Okay. Then Roman number 5. What is the deceleration during the last 3 seconds? Deceleration during the last 3 seconds. Usually gradient velocity time graph ekaka gradient එකෙන් what do we get? Do we get acceleration or deceleration?
Acceleration.
We get the acceleration. And if the acceleration is minus, we can write the deceleration. When they are asking the deceleration, we have to first calculate the acceleration. So last 3 seconds means this section. No? May section එකේ gradient එක calculate කරන්න, first of all, I need 2 points. Then graph එක මෙහෙම යනකොට මේක එක point එකක් නේ. What is the x value of this point? මේ point එකට අදාළ x value එක කීයද? 12.
Yeah.
Then මේ point එකට අදාළ y value එක කීයද? 15. So ඒ අපේ first point එක මේ section එකේ first point එක. So I say this is x1 and this is y1. Then if you take this point, මේ point එකට අදාළ x value එක that is 15. And a point එකට අදාළ y value එක that is 0. So this is our second point in this section. So this is x2 and this is y2. Let's calculate the gradient. So Roman number 2, 3, 4 is here. 5 I method 10. So let me calculate the gradient. Gradient equals y2 minus y1 divided by x2 minus x1. So y2 is 0, y1 is 50. x2 is 15, x1 is 12. So 15 minus 12. So 0 minus 15 is minus 15. 15 minus 12 is 3. So 15 divided by 3, we get minus 5, right? Okay, now what is the acceleration here, Lamai? What is the acceleration here? Quickly tell.
Minus 5 ms minus
Minus 5 ms minus 2.
Minus 5 ms minus 2. Then what is the deceleration here?
5 ms minus 2.
Yeah, minus එක අයින් කරලා we write 5 ms minus 2. So that is how we get the deceleration. Let's move on to the next question. What is the displacement during the last 3 seconds? We know in a velocity time graph, we get the displacement by area under the graph. So if you take this part, the area under the graph is again the shape of a triangle. Here now, Roman number 6. Area, this is a triangle. So how do we find area? half into base. So මෙතන base එක කියන්නේ 12 ඉඳන් 15 වෙනකන් the gap is the 3 now. So the base is 3. Perpendicular height is 50. So half into 3 into 15. 3 into 15 is 45. 45 divided by 2. That would be 22.5. Then we get the displacement as 22.5 meters. Up to this point, is it clear to all of you? Thumbs up.
Yes.
Others? Okay. Now let's move on to the next question. Write down an expression in order to find the total displacement traveled by the object during the complete motion using the velocity time graph. මට මේ මුළු එකේම total displacement එක එකපාර හොයාගන්න පුළුවන්ද? Can I find the total displacement of this graph at once? What do you think? If you take the entire graph, then අපි මෙතන area එක displacement එක බැලුවේ section by section. No? Initially we got displacement 45. That was for this section. Then we got the displacement as 90 meters. That was for this section. Then we got the displacement as 22.5. That was for this section. So we calculated the displacement section by section. Is there a way to calculate the total displacement together at once? බලන්න මම මේ මුළු graph එකම ගත්තොත් එහෙම මෙන්න මෙහෙම නේද එන්නේ. How is it, Maria? How do we do that? If you take this entire graph, yes, very good. If you take this entire graph and you get the area under this graph, the entire graph, මේ මුළු area එකම කියන්නේ ළමයි, can you see that this is a trapezium? So instead of finding the displacement separately, I can get the entire displacement together also. Because if you take the entire area, that entire graph, the area under that entire graph is the shape of a trapezium. එහෙනම් අපෙන් අහන්නේ write down an expression. So expression කියන්නේ we can say total displacement is equal to area of the trapezium. What is a trapezium? මෙන්න මේ trapezium එකේ area එක. So we can say area of the trapezium. Brackets I will say under the graph. Then B part එකේ අපිට කියනවා find the total displacement traveled using the above equation. So then trapezium එකක කොහොමද area එක හොයන්නේ? So you know we have to get the area of the trapezium in order to get the displacement, no? So how do we get the area of a trapezium?
Half into sum of two parallel lines into height.
Yes, very good. Half into sum of the two parallel lines. May ඇවිල්ලා එක parallel line එකක්. මේක එක parallel line එකක්. මේ අනිත් parallel line එක. So if you take this parallel line, what is the length of this parallel line, Namai? May parallel line again. 15, no? 15. So sum of the two parallel lines is so 15 plus this line. What is the length of this line? 6. Yes, the gap is 6. Yes. So sum of the two parallel lines is 15 plus 6. We multiply that by the perpendicular height. So what is this perpendicular height?
6.
6, are you sure?
No.
15.
15. Okay, the height is 15. Okay, so we will do the calculation. Half into 15 plus 6 is 21 into 15. So we have to multiply 21 and 15. 5 times 1 is 5, 5 times 2 is 10, 1 times 1 is 1, 1 times 2 is 2. So 5, 1, 3. So that I have to divide by 3, 2, no? Yeah, 2, ne? So 315 I will divide by 2. 2 times 1 is 1. Sorry, 2 times 1 is 2. I'm sorry. 1 is remaining and I take this 1 down. 2 times 5 is 10. 11 minus 10 is 1. I bring this 5 down. 2 times 7 is 14. 1 remaining. I put a 0 and I put a decimal mark. 2 times 5 is 10. So 157.5. So 157.5 is the area. Therefore, I can say total displacement is 157.5 meters. Is that clear to all of you? Thumbs up, others?
Yes, miss.
Okay, others? Quickly, thumbs up. If it's not clear, you can ask questions. Sanjana, do you have a question? Is it clear? Okay. May total displacement එක මේ ටික add කරලා බලන්න පුළුවන් if whether it's correct. You know, we calculated the individual displacements, no? Here 45, here 90, and here 22.5. ඒ තුන add කරාම ඔයාට මේ total displacement එක කොහොමත් එන්න ඕනේ. Okay? Now we have to copy this down. And you have to write the question here. Can we start? මම මෙතන තියන්නම්. So question එක ලියන්න and then I will slowly scroll down. Okay, quickly start. Don't take too long. We have one more section to finish before we end the lesson. Let's try our best to do at least a part of it today. And එතකොට අපිට next week මාරම චුට්ටයි ඉතුරු වෙන්නේ. Next week we will be starting the third lesson. And we might have a note for the third lesson. මම චුට්ටක් එක check කරලා කියන්නම්. If we have a note, I will send the note on WhatsApp and you can get a printout. Anyways, quickly write this.
Miss, with the question, right?
Yeah, better to write the question here because we are writing an example. So let's write the question too.
Okay, miss.
I will scroll down a bit. Quickly write Lamai.
Miss, can you scroll down a bit?
Yes, I will scroll.
Miss, can you scroll down?
Yes, I will scroll down. I hope everybody's writing. Done, Lamai? How long do you need? You took about 10 minutes now. Who needs more time? 1 minute, okay? Okay. I will set a timer for 2 minutes. Will that be enough, Maria? I will set for 2 minutes. We'll see if 2 minutes will be enough. If you're right. Okay, Lamai, time is up. So our last part of the lesson is gravitational. What is it, Sasheli?
Can you scroll up a bit?
Yeah, like this.
Yes, I just need to write the 7th question.
Okay. So, anyways, as I was saying, our next part is gravitational acceleration. Gravitational acceleration is a bit of a how do I say it? It's not a difficult part, but most often it is a part that you get confused for some reason. ඒක ඇත්තට මෙච්චර අමාරු නැහැ, but පොඩ්ඩක් පැටලෙනවා. I think since we don't have time today to start it, I was wondering if අපිට gravitational acceleration විතරයි ඉතුරු. So I think we will need about 30 to 45 minutes from our next class. Yeah. We will do the gravitational acceleration next day, but you have homework for this week. Can you quickly jump to the miscellaneous exercise on at the end of this lesson? On page 48, there is 47, 48, 49, there's a miscellaneous exercise. ඒකේ homework විදිහට mark කරගන්න.
Miss page number?
Page number 48. Do the third question on page number, the third big question on page number 48, and the fourth big question on page number 49. Third dekai, fourth dekai, 8 questions deka karana balan. As homework, not now. We'll wrap up the class today. අපිට අලුත් එකක් පටන් ගන්න කොහොමත් වෙලාව මදි. So no point starting to just do a bit. But homework, miscellaneous exercise. I hope you marked third question and fourth question. Compulsory. Homework කරන්න නැත්නම් එදාට class එකට එන්න එපා. Right? I don't know whether you will miss the class or not, but if you didn't do the homework, don't come to the class. Because doing homework is very important. That is the level of commitment I need in the class from you. Okay, so I think we can wrap up. Also, my last day, Independence Day, දවස අපි උදේ class එක කරේ නැහැනේ. So ඒකට අපිට දවසක් reschedule කරගන්න වෙනවා. We will keep that in mind, and I think in February we don't have any holidays, unfortunately. මොකද අපිට එක holiday එකක් එනවා මම හිතන්නේ ඒක weekend එකක වැටෙන්නේ. Some poe day or something, that's a weekend. So weekends කියන්නේ කොහොමද class තියෙන ඔයගලන්ට Saturday Sunday usually you have classes, no? So that doesn't work. And another holiday is there on March. But එක holiday එකක අපිට seminar එකක් තියෙනවා. Not for y'all, for new students. I think March 2nd. So එකනේ එදාට අපිට කරන්න බැහැ. චුට්ටක් මම ඒක ඔළුවේ තියාගෙන ඉඳලා ඔයගලන්ට extra class එකට date එකක් schedule කරන්නම්. Not an extra class for that one day we missed the class. ඒකට අපිට Independence Day දවසේ කරන්න බැරි වුණානේ. I'm sorry for that. That was very much of a late notice, but I'm very sorry for that. කොහොම හරි කමක් නැහැ. අපි ඒකට දවසක් දාගමු. And we will wrap up for today. So before we end the class, do you all have any, so all the newcomers, let me know within today and tomorrow whether you will continue the class or not. And yeah, so any questions, any concerns, or is everything clear? If everything is clear, give me a thumbs up. Okay. If you have any questions or anything as such, you can ask. Others? Kushit, Sasheli, Sala, Alia, Senudi, Himansi, Nikini, Dihansa, Jason, Stephanie, Jevindu, Sanjana. All good? Okay. Okay, Lama, we'll wrap up. Then have a great week and see you on 17th. Sashili, did you have a question?
No.
Okay, all right. Then see you next week, Lamai. Good night and have a great week.
Miss,
Okay.
tomorrow we have
Sorry, Shanas?